from our school. Like,
No, you could. No, it doesn't matter. Just so you guys can, as long as you have the ability to interact. All right, we're gonna try to plow through this. I'll probably. What's that?
What's the name? How can I find it?
Let's see.
It's called Free Live College Philosophy Lecture, the Philosophy and Theology of Thought.
Yeah, I try to make that.
Oh, what?
Does your
Free Live
YouTube do this,
College.
Dr.
Go
Schultz?
to
It tries to
channel
make you
called
turn on your
Patristic,
watch
and
history.
then if you click on
Like you can update the settings, but you
No,
can't
I've
like
never
exit
seen
out
that.
of it.
I've never seen that. So if you log in here, if you open this up, you should see something like that. Is that right?
You 12.4,000 subscribers.
It's been stuck. I'm sorry. I should be up a lot higher. I just haven't been. I've been putting all my work into you guys. That's why. It should be a lot higher. I should be up to like.
That's impressive.
That's probably the biggest YouTube account that I know, like from a person, that I know.
Like, look at my friends. I'm not gonna put Jay because he's in another league, but I should have. He's got almost 34. Jim Bob's up to 17. Let's see.
What's Jay got?
Let's see what Jay has.
Jay's pretty popular.
151.
I feel like I'd seen him before I took this class.
What is Kyle at? Kyle jumped up. Kyle's fairly new, and he's already at 59,000. So I should be obviously up somewhere 24 to 50. If I didn't have other things to do in life, but stream, I'm just joking, guys. That's not a knock on. Is your audio popping or is it Arthur J's?
Someone's on it.
I can hear, yeah. I think it's you, Arthur J. It's you, it's not me. Okay. Shall we? Where is my...
That's crazy that these are just random people that are also watching the stream.
I know, it's a weird...
This is a cool dynamic.
Yeah.
We all just be
All right, there should be a way I can share. Am I blind? Yes.
W students.
Why can't I share my...
Is it one of the tabs at the top? Like window or entire screen?
Okay, this is where we left off on. Einstein's theory of time. Remember that? All right, so all of this, and if I pop up, okay, so one of the issues with, should I close that door for me? We had Newton. Remember, we left off with Newton. And we have the mathematics that describes Newton is really based off of Euclidean geometry. And Euclidean geometry is two-dimensional. Do you know what dimensions are? Mathematical planes. So you see in fact, I'll draw a parallelogram because this describes actually if I have two forces here upon an object, it's basically the force will be actually the diagonal drawn on the. Now that I can use that in my formula for force, mass times acceleration, right? Through vector analysis using what's called Newton's parallelogram rule here to describe what's going on in the three-dimensional world. But there's something weird about that. My mathematics is two-dimensional and the world that I live in is three-dimensional. Do you think that's an issue?
You need Euclid.
So we don't get the possibility of Einstein's relativity until we get non-Euclidean geometry. Now here's a mathematician, Bonolo, that I did in school, that basically starts off to develop non-Euclidean geometry. We deny Euclid's postulates, right? These presuppositions. What did we learn is that every science has axioms, postulates, first principles that are not proven but are assumed to do it. So what's interesting is Bonolo attacks a couple of Euclid's postulates. That the shortest distance between two lines, the point that if two parallel lines are drawn indefinitely, they won't intersect. Now, is that true? Well, it's true in a two-dimensional world that two lines formed at right angles are parallels. And if they were to be continued indefinitely, they will not intersect, correct? But that's not true on a three-dimensional object, nor is the shortest distance between 2 points. So we need a new geometry. So we reject that in order to have a new physics. It's compatible with this. And so we live in a three-dimensional world. In fact, we add one more dimension. So this is space. Remember, we were talking about every theory needs a theory of space and time. And then really I should say time is the fourth dimension, what's called space-time. Now I could do obviously this. I have two dimensions, right? My vertical and my horizontal, of which I can have the XY coordinates. What do I do to get three-dimensional? I add a Z coordinate or something like that. And so not only can I have a two-dimensional triangle, I can have this, right? I could have a three-dimensional. Now let's try to like space, right? That represents space. Now it's very difficult for me to, on a two-dimensional board, to even write three-dimensional. I could do it. You get the idea. Here, what the heck am I going to do to add a fourth dimension? I'm running out of options here. So what do you suggest? So each point here is clearly a point in space, correct? I've represented three dimensions. I need a fourth. I'll have each point be the space-time point. So not only is that going to represent space, right, as it does, obviously, but space-time. Now this is going to blow your mind and have some really bizarre consequences. It's clear that I'm standing in a different space than you. The implications of this is if each point in space is also a space-time point, what does it mean about you over in the back of the room? You're obviously not only in a different space, you're in a what? Different time. That seems counterintuitive. That's weird. We're experiencing things in the same time, correct? Or is that perhaps, and as we'll see, the speed of light has something to do with this equation that we're going to talk about. Now, just like sound, it has a velocity, doesn't it? It takes time for the sound to get to another place. It also, well, think about this. Suppose we set up a balloon at the end of the room, and I have a gun, and I shoot the balloon. Now, the trigger, the bullet being fired, and the balloon popping would all seem to be instantaneous. But we know it's not. One happens before the other. Why does it all seem to be happening at the same time?
Because of how fast it's going.
The bullet's fast. It's probably going 700-800 miles per hour. I mean, it depends on what I'm shooting, and we know that if you go faster than that, you can go faster than the speed of sound, right? And so you can get to the other place before the sound actually gets there. Now, what about light? Light's pretty fast, a lot faster than. As we'll see, light determines events in space-time. So the only reason why it seems like we're in the same time, even though you're in a different space, is because, look, if a bullet going 700 miles per hour seems instantaneously to the popping of the balloon, think about even more so with the speed of light. It would be imperceivable until what? Unless they do really great distances. I would start to see, just as we know, if you look and you see a supernova, at that space-time point, that's long, from that reference frame, that's long gone, isn't it? But Einstein is a rejection of Newton's absolute space. There is no privileged absolute position, reference frame, in which you could say, oh, well, that's actually gone, and by the time you see it, that's just the after effects. The consequences of this will be no. It's actually, that event is not just taking, like the sound, time to get to you. It's actually happening for you at a different time then. And that's going to be bizarre. And we're going to have a series of experiments, thought experiments, that are going to illustrate. How many people do we have in the house? 32? That's supposed to prove this. Any questions about that? Okay, this is the theory of special relativity. And in order to, one second, I'm gonna pop. In order to see that there really is no absolute reference frame, what we're going to do as far as space, time, and velocity is we're going to hold one constant and see what the conclusion is of another. So in this, we're going to hold, what do you think from the slide is going to be held constant? So we have a person, let's call her Jane. She looks like in a dress, and I don't know, it's Jane, Jane, neither the J here. Come on, help me out. Who's the dude juggling on the train? Jimmy and Jane. And in this scenario, we're going to have, from Jane's reference point, she's stationary, and Jimmy's moving in the train with, okay? One second, I'm trying to pull something up. Shoot. Does everybody get what's going on? So what's going to be held constant is that the speed of the train for Jimmy is the same as the speed that Jane is actually observing. Does everybody get that? I hate that when you try to log on to your email, it always, do you get these push Okta or whatever, the verification things? Drives me crazy. Okay. So what is Jimmy doing? There's a ball going up and down, correct? So in space, what is it tracing out? A straight line? Shoot. Can't find this now. He's throwing the ball up. What is he? You're Jimmy. He's throwing the ball up, and it's in space, tracing out what? A straight line. Okay. So it's doing this and this reference frame. But this reference frame, R1, is given a velocity. Jane is reference frame 2. Okay. What is she seeing? Because I have two velocities here, correct? And similar to Newton's parallelogram, in this situation, it makes a what? Once I have this velocity, the ball makes a parabolic arc, correct? From Jane's reference point. So my question to you is, well, what is the ball actually doing? What is it actually tracing out? A straight line or a curve or a parabolic arc? Curve. You say curve. What do the rest of you say?
Straight, it just looks curved because of where you're standing.
Depends on the reference point.
Depends on. One second.
The ball is moving in the X direction. has two-dimensional velocity.
Both. So your problem is you're assuming a Newtonian absolute space. It's got an absolute space would determine space-time would determine it has to do either one. It's either doing tracing out a straight line or both. But if there is no absolute reference frame, because absolute reference frame would assume a two-dimensional, four-dimensional world would mean there's different points in space-time, then there is no absolute reference frame. It's relative. So relative to Jimmy, it's doing a straight line. Relative to Jane, it's doing a parabola. Okay, so let's go next. Well, what happens if instead of holding the velocity constant, I hold space constant? If I hold space constant, we get in here the experiment, the thought experiment of the simultaneity, the relativity of simultaneity. In this situation, notice it's always trains. Does anybody know why? Because Einstein worked at a patent office coming up with a patent for, well, we have the trains coming across the United States and the way we have different time zones. So it's likely that he's thinking about what? Time and motion. And okay, in this situation, I need to have space held constant in both reference frames, okay? So what is this? By, ay, where's x? XA, it doesn't look equal, but so XB is going to be, I'm going to make them all equidistant, is equal to XA, which is equal to BY, which is equal to AY. That's what it would mean to behold space constant, correct? Now I put Jimmy again, or maybe I switch out, maybe it's Jane because this is a term. And I give a velocity. Velocity. And in this experiment, it's the velocity is going to equal 3/5 the speed of light, which is I don't know, 100. Somebody look at 144 kilometers per second or something like that. It's a really fast train. It's faster than the bullet train. Okay, now for this to make sense, I'm going to freeze frame. And when I freeze frame this event, there's no motion in the freeze frame, right? So this isn't going to get closer. I just want to determine what that value is in the light of the distances. Okay. Now in this freeze frame event, when I take the photo, there's a lightning bolt that hits A and B. Same time. I'm at Y and I'm looking. And the reason why I can see them happen at the same time, because light, the speed of light is constant. The distance is constant. And so it will take the same time to cover the same distance by which I see from my reference point Y them happening simultaneous. Does everybody follow me so far on that? Okay, what's the only thing that's different? My velocity is 0. This velocity is 3/5. That's the speed of light. That's the only thing different. This distance doesn't change. Why? Because I freeze framed it. So I can get all the values, so they're not changing. So all things being equal, so it doesn't change. If I notice something different, then I can isolate something. Okay, here's the question. What does person X see from their reference frame? Do they see it happening at the same time? Do something like that. Thoughts? What does the person in the moving train see?
Is the train moving towards A?
Train, yeah, sorry. Train is moving. I should have put that this way. Oh, shit, I moved the line. 1, 2. I'll put the slide up again. I want to share. Keep trying to send this to myself. And it won't. Any thoughts?
Is he looking during the same time that
Yes.
person A is looking? That like freeze frame?
Yes.
Would he see the lightning bolts? Would he have seen the lightning bolts earlier? Because he's traveling closer to the speed of light?
Yes, but why?
Because relative to him, the lightning bolts are going slower.
All right, say that to the class. Hold on, let me just put this on share. Keep hitting the wrong. Why does it do this? So I want the PowerPoint. Oh, did I have to do window?
Yeah.
Is that?
Wouldn't you see the right lightning bolt first, though? Like quite a bit before.
Yes. Now, your temptation is to say, well, because he's getting closer, right? So the amount of distance that the light has to travel. So he's going to see this. Person in the, or she, I guess, because
Can't see anything on the video.
moving this way. Now, the speed of light's constant. So that's why it takes the same distance the person at y to see that at the same time. Why? Because the speed of light is constant and the distance are constant. Okay? So I should, if I'm the person traveling, see also, right? Because the light's going to have to travel the same distance to hit me, and it's going at the same speed. But there's something about the speed that changes time. Now you're thinking, oh, you're moving faster, you're getting closer. But that's why I freeze framed it. I'm holding this distance equal. So yeah, if this is moving and this is moving, then of course I'm going to see this first. But that doesn't make sense if I freeze it so, yes, but if I hold the distance the same as this distance, he should, in an absolute reference frame, according to absolute space and time, see them simultaneous too, just as the person. Why? Because the speed of light's the same and the distances are all the same. So that means when I hold distances constant, it proves and shows to me the relativity of time. Notice the other one was if I held velocity, i.e., because the formula has time in it, constant, it shows that space is relative. If I hold space as relative, i.e., distance, then it means time's relative. Events are happening at different times in the same distances. That's crazy. So move on. This brings up the time dilation is what we call this. And basically, let's think of a twin, and it's called the twin paradox in light of what we just thought and concluded. So there's two twins. Obviously, one's a used car salesman or a businessman, and the other one's an astronaut, correct? Twins mean they're the same age. Now, he's built a space machine, flying space machine craft that goes close to the speed of light. And they both have their watches set. And they say, okay, you're going to go away and for a year, and you're going to come back and we're going to meet. Okay, so they set a clock here. So see this, we have two different reference frames. We have her down here again. And so this will be the tick of clock, right? I can make a clock by just bouncing a ball. 1 second, 2 seconds, right? Back and forth, okay? Now, what the twin's going to see on the Earth is this, right? Going back to the relativity of the moving train, that ball is going to have to trace out longer distances, correct? Relevant to that. If that's true, then time's different. So they come back, and the twins, after a year, 1 year, the twin is aged 10 years. So what that means is that the clock actually is moving slower in the spacecraft than it is on Earth. Is that crazy? Do you believe it? Is that possible? the same clock. So there's nothing different about the clock. The only thing different is the velocity. The faster you go, time will slow down. So what that means, an atomic clock placed on a jet airplane, and we've seen this, was actually shown to tick slower than an atomic clock at rest. So even with the speeds achieved by a jet aircraft, the time dilation effect was minimal. So let's go to a more solid example that can be seen through an experiment performed on the International Space Station. After 6 months in space, the crew of the International Space Station aged 0.007 seconds less than the rest of us on Earth, the relatively stationary objects. The station moves, if you don't know, at 18,000 miles per hour, much faster than the range of normal human speeds, obviously. But even with such speeds, however, time dilation is minimal. So we only get 0.007 seconds. But at least we have a formula such that if we were to check it, yes, if you went to the speed of light for every 1 year, it would be 10 years on Earth. Now, obviously, this is going to open us up to theorists thinking about the possibility of time travel. What we know from according to physics and Einstein's theory of relativity, we would have to be able to travel faster than the speed of light in order to accomplish this. Something that physics tells us and that's impossible. Because one of the constants, what's determining all this, events happening, right, in we're at different times, right? So experience time differently once I add different velocities. And that has to do with the speed of light. So for example, when I said here, a star blows up. Okay. What determines this event, E1, at ST1? Light. Light is the determining factor of the reality of that situation. And it's going to take, right, here I am on Earth. What I see will be at a what? Different space time. But it's going to be, it's not a different event. It's not like the event happened and then I'm just seeing the event. It's the same. The reality of the event is contained within light. So think about it this. I have a slide that maybe makes it a bit easier to see. Here's the speed of light. 282 miles per second. So you look out in space, all of that's done. It's gone. From their reference point, those stars no longer exist. Yeah.
There's a good question in the chat.
Oh, let's see. Thank you. If questions come up in the chat, let me know like that. Okay, is it Vigo?
Yeah.
I heard recently quantum physicists discovered that the speed of light isn't constant. Do general and special relativity, there is a clash between quantum mechanics and relativity, just as there is a clash between this and Newtonian physics. This is why you have some scientists saying, we need a theory of we need to bring them all together and show how they're compatible. But that's right. In quantum mechanics, the speed of light isn't constant. But notice you have these kind of different axioms and principles. In Newton, you have certain principles and axioms that are different than Einstein's relativity, correct? And then quantum has different ones too. They seem to be incommensurate. They don't all work together. They can't all three be describing reality. You can't have a two-dimensional system describe 4 dimensions, correct? And you can't have the world of quantum mechanics describe reality and at the same time this. So it is a problem. There are some people who think they can resolve it, but yeah, great question. But just to understand how Einstein's relativity works, we're holding the speed of light constant. Okay, good question. Good job, 49. Let's get those numbers up. I came to this realization when I was studying optics in Einstein's relativity in undergraduate. When we were doing optics, doing Newton and optics, we did sort of kind of a camera obscura experiment. Does anybody know what a camera obscura is? You might have had an experience with this with the eclipse. They say never to look at eclipse straight with your eyes, but I say they're liars. So you use you make a camera obscura, right, where you have the image come through and be displaced onto like something in a box or like it operates like a camera. Okay, so we could do this experiment in a classroom. In fact, we did. If we covered up the windows, shut out the lights, you wouldn't see anything, correct? We see things by virtue of light. Okay, so if I then have a room, okay, I have things outside of the room, apples, and let's say birds, okay. And normally you'd look through the window and see that stuff. You can't see it. All right. Board up. Here's the window. Okay. But then as I board this up, cover it up, I put a little pinhole. Now light can come through the pinhole and then it's going to come out, right? And guess what you're going to see? You're going to see the image. It's going to be upside down on the wall. Now, it's not just an image. What I notice on it's moving. In fact, this is how we use, who has a piece of paper, white piece of paper?
Lines okay?
Yeah. So if I hold this up, what do you see on the paper?
The projector.
The image, right? And obviously it gets blurry. That's why in a camera you can do this. It's what we call the focal point. You can determine mathematically as far as the distance, what actually is the most accurate image of it. This is like a plane, and I'm slicing. That means that image is actually in the light. I can just make it visible to you by slicing it like this. Then I start thinking about, I'm like, that's crazy. The reality of that event is occupying every point in space, whether I see it or not, and I just take a plane to actually slice it, right, and make it visible. So that's why I have this kind of graph up here. I could reinterpret. I was trying to connect kind of Newtonian stuff of optics with like Einstein's. That it was like, well, what if that's right? What if reality is contained in the light? That means it's not that I'm just hearing a past event or seeing a past event that's in the past. it means from once it hits me, that is actually event 1 is actually happening. Even though if I switch my reference frame, if I'd be there, it would be gone. Does that make sense? It's kind of weird, huh? It's kind of mind-bending. So if I could get back here, it would actually be happening. Like instantaneous, if I, get there. It would be happening before it happens. Now that's language of possible time travel. If I can get back to something before it happens. Marty!
Is it kind of like how people theorize that if you're like in a different galaxy and you looked at the Earth and observed it, it would be in the past, like by years?
By your reference frame. Yeah, well, that's odd. So from that reference frame, at your time, it would be the past. Is that right? Hold on.
I think that's right. Like
From your reference point, you're looking.
Like if I were to travel really far away, faster than the speed of light, turn around and have a telescope, I could see an older version of the Earth.
Or you, yeah, that's what I'm trying to say. If this is the speed of light, so when this happens, you're looking in one sense relatively in the past. In another sense, you're not. You're actually looking at the Earth in the present from your vantage point. So what's interesting though, so that means the actual time is in the speed of light. The actual event is in the speed. So when you see it, you're seeing it happen, right? You're looking back. But what happens if I could go faster, like you said, than the speed of light and get back to that point? I could go back into the past. Is that what you're talking about?
Sense? No.
So then you could see your past self.
You see your past self.
So what does that mean for? Does that kind of like break the idea of presentism? Of the only time that's real is the present.
Yes. So that is, remember Taggart's A and B theory. So what was the presentism? And we'll talk about this when we get to Augustine, but there is no privileged time point, correct? So that means all points that you would consider, this would either be my present past, you have to start qualifying, my present past, so it's presently happening, but from my perspective, or from their perspective, it's the past. Then you can have past futures and stuff like that. There is no privileged point. So all points in space, which you would call past, present, future, in this model, all exist. Whereas this, the only thing, in presentism, the only thing is there is no future. And this, there actually is a future. And it actually exists as a space-time point relative to, this is the future, which is before the speed of light, before light gets to it. And these are the past points. So yeah, if I could go faster than the speed of light, I could actually get to the past or my present before it happened, i.e. past. Okay, so there is no privileged point. But in presentism, there is no future point or past point. The only thing that exists is the present. So that's why I had you read the Taggart A and B theory. Good points, no pun intended. But I can't go faster than the speed of light. in Einstein, so what do? I throw away Einstein. Isn't that the best thing? And then we learn philosophy, when you get stuck on something, just throw it away. But like, well, I don't believe in it. To do that, I believe in quantum. Now, quantum mechanics, we've been joking in the last class, is like sorcery, right? It's like magic. Anytime you don't like something, just do the magic words. Quantum, listen to my words, quantum. Yeah, but in the quantum seafoam entanglement multiverse of Doctor Strange, I can do whatever I want. And I win every argument, right? Because I have a multiverse of an infinite things where I've already done the argument and won. I'm joking, but kind of not. So what if so suppose I can't cheat, can't go fast on the speed of light. If these are different, if we think of space-time as like a fabric, like this, we know, by the way, gravity is, this is the general relativity of heavier objects actually change the gravitation, the time dilation. So why? Because it bends the space-time fabric, right? The heavier an object is. So time will be different in larger massed objects. And if you want a visual demonstration of this, go watch Interstellar, right? They get to Gargantuan, I think was the name of the planet, and time, so the closer they get to it, the time starts changing, right? So when they come back, what the scientist who was on the spaceship had gone through 10 years. For them, like 15 minutes, or it wasn't 10 years, but whatever the time. And then they talk about the possibility that I'm going to talk about, a wormhole. So suppose I can't go fast in the speed of light. What if I'm understanding space-time fabric is like a cloth or a fabric, and yeah, if I could get back to the past from my present before it happened, then I travel in time, but I'd have to go faster than the speed of light. Can't do that. But what if I could bring two points in space together? Then I could bring my present back into the past. That's time travel. Obviously, it doesn't look like you can go into the future if the future means what hasn't happened yet. But you could talk about future relative to certain points or something like that. Okay, well, let's just focus on this and go back to the past. It would have to be something that theorized gravitation so strong that it creates a wormhole, and that's what Matthew McConaughey goes through, right? We all know. We're learning science through Matthew McConaughey. My God, look at that wormhole right there. Right? That's Matthew McConaughey. And anyways, he can go to a different point. I think it focused going a different point in space. But it would mean a different time. So that's a possibility of time travel. Now, this presents some theoretical problems that theorists have basically say, hey, just because you can explain that doesn't mean that that's possible. Because what constrains all physical reality? Logical possibility. And what the problem would be is what? If I can go from this point back into the past, here's my grandpa, right? Can I go back into the past and kill my grandpa? Then there wouldn't be any grandpa to have me exist to go back into the past, but that would be possible. So it's possible and not possible at the same time, the same way. This is a paradox of time through time travel. Here's another one. It's illustrated in the movie Somewhere in Time. The movie starts with an old lady going to Christopher Reeves and giving a watch. Okay, so here's a time point. And she says, come back to me. Okay. Through the series of the movie, he studies, going through time, a theory of time, philosophy of time. And gets this idea of, he reads a book, The Possibility of Time Travel. Remember, if time is the measurement of motion, if I can get all the motion, the physical reality, three-dimensional realities determined, and my mind, right? Because what did we say earlier? Time is, at least from the Aristotelian point, the mind's measurement, the experience of motion and the measurement of that. So what happens if I could get all the motion, the physical objects to be identical with some, let me put this here. Let's say here's the watch, come back to me. To some point in so I think the movie's like 1979, or let's do 82, right? What if I could get everything in space and my mind, because mind would entail time, the measurement of motion in space, identical to some point in space. So there's nothing in my mind that's separate from 1911. There is nothing in the physical space that's separate from 1911 at this certain place, at this certain hotel. Could I actually time travel? So he does. He gets to this point in space, at a different point in time, sorry. He time travels and he meets a lady and he falls in love with her. And guess what he does? He gives her a watch. Okay. Then something happens in the movie in which he finds a penny from 1982 that changes this and it throws him back here. She waits with the watch all the way to 1982 to give it to him to say, come back to me, I've been waiting for you. Okay, here's the question. Where did the watch originate? She gives it to him, but she only gets it because he goes back into time so that she gets it. Yeah, but where did the watch come from? Paradox of time. So those are some issues that could arise that would constrain the possibility of time travel. Keep this in mind here. Aristotle's definition is the numbering of motion with respect to before and after. And if you think about that, kind of makes sense. You look at the clock, is that time? No, it just measures time. Am I walking and moving? Is that time? No. Aristotle says it's the two motions that you take when we take something in motion, me, and then the second hand, B, and understand by relating them, there's something in between. And there's time. That's why Aristotle would say you can have motion without time. A, me, is not time. It's motion. B, the clock moving is not time. It's motion. Then what do? To get an objective understanding, I measure it. The quantity, the distance in which the object is moving. Right? There's a given distance here, and there's a given distance on the numbers of the clock, of which the numbers you have before and after with respect to the motion of and there's time. That's kind of interesting definition. So know that for the exam. Let's move to St. Augustine's notion of time. Now, he's going to have a theory of presentism. And this arises through his treatment of time in Confessions, book 10, that, okay, time obviously implies duration, doesn't it? In fact, what do we mean by time? But a duration, a given time. So does time exist is the question. Time exists, duration must exist. Let's take a duration. The day. A day is composed of 24 hours. Does 24 hours exist? What does exist mean? Exist, to be, is. Is 24 hours existing right now? Does the day actually exist? It's like, no, part of the day. Wouldn't you say that? What time is it here in Montana? 12:04. Oh, that's an hour, okay. A day is composed of 24 hours, of which we're right in the middle. So, hey, look, the hour exists, right? 1 hour. That's got to be a duration. Does the hour exist? Are we experiencing an hour all at once? No. We are what? 4 minutes into the 12th hour, right? So an hour is composed of 60 minutes, of which we've only experienced 4. Okay, so the minute must exist, right? 1 minute. Is it existing? No. Minute's composed of 60 seconds, of which, do you see where this is going? Milliseconds. Well, what's actually existing? I mean, something has to, but I can't ever get a quantity on, Augustine says, the now. The now, and Aristotle talks about this too, seems to be the only thing that exists. But the now can't be an extension. Like this, like a line, a distance, a given quantity or duration. The duration is all, it's like a point. A point has no extension. A point marks extensions, doesn't it? What do you do with the line? The extremities of a line, or put a point here, right? But it has no extension. And the now is like that. So how is it then I perceive time? How do I talk about time? Because that pretty much, if the now is all that exists, well, that's pretty much the closest thing to nothingness with actually not being nothing, correct? Yes.
But doesn't that kind of, like, I mean, our reaction times are like in the milliseconds, 200, 250. I mean, reacting to light, reacting to just a whole bunch of things. So couldn't we quantify it in that sense that like the now is within like 200 millisecond intervals continuously?
But you can break those down and break them down infinitely.
But we won't be able to perceive them.
You wouldn't be able to perceive it. But when you're actually saying, yeah, but what, I mean, obviously what exists versus what you perceive exists are two separate things. So if you want to know, yeah, but what actually exists, I need to find that first before I can actually say, okay, then what am I allowed to perceive or what can I perceive or something like that. And I can't ever get to any extension. So I'd have to conclude it has no extension. It has no parts. There's no more parts. You can't divide a point mathematically. And therefore you can't divide the now, the only thing that exists, any further. So Augustine says, you live, your reality is an ever fleeting now. It really is the closest thing to nothingness while still existing. And I can't name it. Remember, Heraclitus is down the river in a van down by the river. We got that. The now is in a van down the river that just floated away. And so then I'd have a problem. I just have a series of points that have no and they're not connected in any way. So like all of this would just simply reduce to a point. So how is it that I do perceive succession and that I think these are actually tied together so that I actually can have something called perception? Because think about it. If you're just experiencing another point that's different, that has no extension, it's like you have amnesia, right? Or dementia. Every new point, every new now wouldn't be connected to the previous now because it's a new now. And you'd be like, wow, it's a surprise to me. It's a surprise to me. Well, who are you guys? Who am I? Help! Right? I would be like crazy. And I've had this experience by hitting my head once and getting where all these points that I had in my mind of what past and future and present and got all scattered. They weren't continuing. And I started to like have a really difficult time. All right, so what Augustine's solution to this is descent to anime, the soul. What the soul is an extension. Or the mind. The mind has these mental categories. Like it stretches out and makes a past as if the past had an extension, but there's nothing out there. They're just mental constructs, sort of like Kant was saying, right? What did he say? Space and time aren't out there. They're the necessary conditions in your mind, the forms of intuition that make perception and experience possible. You could say, well, hey, you know what? Augustine predated you and figured that out. Let's see, what's Augustine? 400s, Kant is, almost 1,000 years after or before. So I create these categories, mental categories, in my soul or in my mind, right? Why? So that I can grasp an ever-fleeting reality that would not be intelligible. And then I perceive as the now, the only thing that exists that would be an ever-fleeting within the categories. Now I have a connection. By the way, this actually anticipates and predates Husserl, a phenomenologist that has a theory of the phenomenology of time is extension. So 1 foot of your mind through the phenomenological experience of the world, when I hit the middle C, it's connected to what? The last middle C that you heard a couple seconds ago. Are you surprised to find out in the next seconds it's the same C? How do I do that? By a stretchedness. I stretch. In terms of phenomenology, Kierkegaard says we understand backwards and we lived forwards, right? And you get this in Heidegger and different things like that. Okay, what do we have? 3 minutes. I wanted to. Was it black the whole time, the whole screen?
No.
Okay. One problem that arises is that maybe you've thought about this. Well, if God exists outside of time, and he foreknows, he's omniscient, he knows all things. He knows in the future I'm going to eat a cheese omelet. And nobody has the power to undo, given the definition of God and the immutability of God, his knowledge. If he's always foreknown something, who are we in the power to undo that? And if he's always foreknown that I'm going to eat a cheese omelet, do I have a choice to eat a cheese omelet? So it looks like we're all determined. You thought that you had a choice to come in the classroom, but God's foreknowledge determines that. Well, one way is that look, you run into a problem because it's the way that you're thinking about time. You've misconstrued it. Okay, Augustine says if you're an ever fleeting now, God is an ever present. These categories are not objective. There's no, again, it's a rejection of, what is it, A theory? A theory is, pull that up. A theory is presentism, B theory, right? Look up real quick, I just confused myself. Interesting enough, what you would call your past, all your past or futures, God just sees in one fullness of now. Yours is ever fleeting. All of this is just present before God like multiple objects. So the reason why he knows that you're going to eat a cheese omelet and why you still have free will is, and in some sense, he lets you determine his knowledge. My knowledge of you touching the pencil on your paper right there doesn't cause you to do it because I'm simultaneously existing with you. I know it because you did it, and I'm there with you. God knows what you would call is the future from your reference frame, because from his reference frame, he's just present there like I'm present there with you. And just as my knowledge doesn't determine what you do, God's knowledge, which he's always known, doesn't determine what you do. And in fact, if he's ever present ever now, we really don't apply these categories to God. And ever present now doesn't have mental categories of past and future. This is our tensed language. What gets to the problem, we'll end with this. Why? The problem isn't with God when we ask the question that Augustine asked, what was God doing before he created time? What was he doing in the time before he created time? The problem isn't with the reality that signifies. The problem is your language and categories. Can't always apply to everything. I can't apply and talk about what's prior to words without using words, what's prior to time without using time that would imply time. And likewise, with the situation, if I don't recognize this, the finitude and the tense of our language and the issues with that, I'll run into problems that God's divine foreknowledge would actually determine us. So this gives us a way out of saying, no, God, you determine God's knowledge, right? Without changing him. And his knowledge that he's always known doesn't determine what the actions that you do. And so I wish we could go into more on that, but that ends. There's so much more that I could send you the paper on the theology of time, because this really opens up a whole new kind of dimension to think about time in the world through a theological lens. But all right, any questions on that before we leave? Let me just see if there's any super chats here. And I will end this stream. Thank you, everybody in the chat, for joining us. Until next time. That ended stream. And
DuckDuckGo.